Let's learn about proof by mathematical induction. Here's a classic theorem. Suppose you were asked to prove that the sum of the first n natural numbers from 1 to n is equal to n times n plus 1 over 2. Now you first try the equation for n equals 1. 1 times 2 over 2 is 1. The equation holds true. Then you try n equals 2. 2 times 3 over 2 is 3. That's also true. So every number that you test, the equation always holds true. But how do you prove that the equation is true for all natural numbers greater than or equal to 1? Now let's look at a different but equally important scenario. Let's suppose we're on the boat of the Titanic, and Jack is proposing to Rose. Jack is certain of the proposal, but Rose has some doubts. What if you stop loving me one day? She asks Jack. Jack, always quick on his feet, claims that he can prove it to her. I'll prove my love via mathematical induction, Jack says. 2 things are certain to me. 1, that I love you today. And 2, since love is eternal, if I love you one day, then I'll love you the next day. And by this proof, I'll love you until the end of time. Poetic licenses aside, Jack's argument is actually a good example of mathematical induction. So Rose accepts Jack's proposal. And they live happily ever after. Or until the iceberg showed up. Now let's go to our original problem. For mathematical induction to work, we need to prove 2 components. First, the base case is true. And second, that the inductive step. In our base case, n equals 1. And we can easily prove that 1 times 2 over 2 is 1. For the inductive step, we'll assume that the equation holds true for one number in the sequence of natural numbers and prove that this implies the equation will hold true for the next number in the sequence. In our example, we assume that the equation holds true for some number n and prove that this implies the equation will hold true for the number n plus 1. This is equivalent to the eternal love from day to day part of Jack's speech. And just like Jack, we are now certain that our equation holds true for all natural numbers, no matter how large it is. A few things to know about mathematical induction. First, the base case does not need to start with 1. We can just as easily start with the numbers 4, 5, or 10. Similarly, Jack could have started his argument of love with how he loves Rose yesterday, or 2 weeks ago, or a week from now. And you'll still try and convince her that his love will last forever. Now, the second thing to keep in mind is that, like a line of domino cards, mathematical induction only goes forward and not backward. So if we start with the base case of 4 and prove that n implies n plus 1, the mathematical induction will say nothing about whether the equation holds true for the case of numbers less than 4. Or in Jack's case, just because he's certain that he loves Rose today and that he will love her forever, it says nothing about how he feels a month ago before he's even met Rose. Just like love, mathematical induction can seem mysterious, almost like black magic at first. But when you try and practice it enough times, you will start to develop an intuition for it.